My name is Garrett Hayes, and my review focuses on the impact of meal timing on glycemic control and chronic disease risk. Glycemic control is essentially the body's response to eating food or eating a meal. In a normal person, when our glucose level spikes after we eat a meal, our insulin also spikes to make sure that glucose gets into our cells, and you would see those levels drop off in the hours after a meal. But in those with prediabetes and diabetes, their glycemic control is impaired, and you would not see that same drop. And then this impaired glycemic control is also indicative of other metabolic diseases like metabolic syndrome, and then they're also linked to other chronic diseases. So chronic disease, many of them are preventable. The ones we're talking about today are like heart disease, diabetes, and obesity. Many are not, but they account for the vast majority of US's annual healthcare spending. And specifically the ones we're talking about today, heart disease is the #1 killer of Americans, and diabetes ranks number 7. Our first paper explores glycemic control in pre-diabetics. Um, as you can see from the title, the glycemic control does decline in the evening, but they also sought to understand what exactly becomes impaired. It's a relatively small sample size. There were only 10 subjects, but they're all pre-diabetics. And the researchers administered oral glucose tolerance tests 12 hours apart at 7 a.m. and 7 p.m. Blood draws were taken at several intervals over a 3-hour period after the OGTT was administered and assayed for insulin and glucose. So you can see here the results of the trial. Pretty straightforward. You can see here in the top left where you see the morning is represented by the circles and the evening is represented by the squares. You see a pretty equal spike, but after 3 hours, you can see that in the morning, the blood glucose is essentially returned to baseline. Actually, it's a little below fasting, whereas the evening blood glucose is far, far above that, and extremely statistically significant as well. And then you can also see statistically significant decreases in insulin sensitivity and beta cell function in the evening. So as you saw, blood glucose was significantly higher after 3 hours in the evening compared to the morning. And we saw significant decreases in all these metrics in the evening compared to in the morning. Our next paper focuses on this same decline in glucose or glycemic control, but instead it uses a low glycemic meal rather than just an OGTT. So these researchers wanted to understand whether this same decline in glycemic control would be seen in response to a low glycemic meal, and if it could be manipulated with meal timing. The subjects all had a normal BMI range so none of them were underweight, none of them were obese, females and males aged 18 to 50. The OGTT group, there were 10 of them, similar to our last trial. There were OGTTs administered at 8 a.m. and 8 p.m., and the blood was assayed for glucose only. And then in the interventional trial here, they were given a low GI meal, which they described as with a GI below 55, and there were 9 of these. And they gave these meals at 8 a.m., 8 p.m., at midnight, and blood was assayed for both insulin and glucose. This low GI meal was a tomato-based vegetarian pasta dish. So here for the OGTT trial, really similar to what we saw in the last study, where we see the blood glucose spike higher and sustain longer in the morning versus the evening. In the low GI trial, you can see here that these are represented by the evening, and you can see that blood glucose spikes higher in the 2 evening trials compared to in the morning, and you see the same kind of effect in the insulin levels, but to a lesser degree. So for the OGTT trial, just like the last study, they found a significant difference between the morning and evening glucose levels. And then for the low GI trial, they saw a significant difference in blood glucose at the 2 evening meals compared to the morning meal. And they also saw a significant decrease in insulin levels in the morning compared to the 2 evening trials. Our last study is a cross-sectional study that recruited from the PISA study to identify the relationship between breakfast eating behaviors and atherosclerosis risk. So these, like I just said, these subjects were recruited they used existing data from the PISA study, which stands for the Progression of Early Subclinical Atherosclerosis, 4,052 participants in total. And these participants were grouped based on 3 breakfast eating behaviors. First is the high energy breakfast group, a low energy breakfast group, and then a breakfast skipping group. And they used regression models to identify if a relationship existed between their breakfast eating behaviors and CVD risk factors and atherosclerosis. So here you can see the odds. These are all odds ratios. So A here shows the odds ratios for obesity. You can see that these breakfast skippers had the highest odds. B is the odds ratio for metabolic syndrome. You can also see that the breakfast skippers had the highest odds. And then C shows the odds ratio for atherosclerosis. And you can also see that the breakfast skippers had the highest odds. This chart shows the prevalence of atherosclerosis and other or different types of atherosclerosis for the 3 breakfast groups and compares them to the general population, which is in red. Similar to our last chart, you can see that the heavy breakfast eaters had the lowest rates across the board, with the breakfast skippers having the highest rates. The breakfast skippers also had higher rates compared to the general population, and the heavy breakfast eaters had lower rates compared to the general population. So like I just described, across the board, the high breakfast eaters had lower rates of obesity, metabolic syndrome, and atherosclerosis. And those eating the large breakfast also had the lowest prevalence of chronic disease and chronic disease risk factors. And we saw the exact opposite in those eating the smaller breakfasts. So to summarize, these trials, the first 2 trials show that glycemic control declines in the evening, not just in pre-diabetics, but in healthy people as well. And this could point to our bodies being more optimized to handle the load of our daily calories in the morning rather than a load of calories in the evening. And then based on our last cross-sectional trial, those who are eating large breakfasts, they defined breakfast as eating before 10 a.m. They show lower rates of CVD risk factors and atherosclerosis compared to the general population. So I think a lot of further research is warranted based on these studies. Of course, the first 2 trials had relatively small sample sizes, so I think it's necessary to confirm what we found in those trials with larger sample sizes. And these trials just explored the spikes in glucose and insulin, but insulin does have a role as an anabolic hormone, so it does serve a role in fat creation. So if we were able to understand how insulin-mediated lipogenesis changes throughout the day with higher or lower insulin levels, we could come to discover how 1 calorie in the evening could be much more fattening than the same calorie in the morning. And then I think the overall takeaway from these trials and this review is we need more research that manipulates meal timing as a weight loss intervention. And in doing so, we can discover if what we eat could be just as important as when we eat it. Thank you.